Lesson 11-5, solving systems of equations using inverse matrices. You have learned in previous courses that the product of a real number and its multiplicative inverse is 1, which is the multiplicative identity. For example, 3/4 times 4/3 is 1, therefore 3/4 and 4/3 are multiplicative inverses. We also refer to them as reciprocals. For matrices, the identity matrix is a square matrix that when multiplied by another matrix of compatible dimensions, it equals the same matrix. So a 2 by 2 identity matrix is going to look like 1, 0, 0, 1. A 3 by 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. So you'll always see a listing of ones diagonal from the upper left to the lower right. The identity matrix for multiplication I is a square matrix with 1 for every element for the main diagonal from upper left to lower right and zeros for all the other elements. For a square matrix A of the same dimensions as I for the identity, A times I is the same as I times A, which will give you your A matrix. Two square matrices are inverses of each other if their product is the identity matrix. So the inverse of matrix A is denoted as A superscript 1, -1. And the product of A and A superscript 1 is the identity matrix. So the inverse of a 2 by 2, when you're multiplying by its inverse, you should get your answer to be looking like this, 1, 0, 0, 1. Not all matrices have inverses. Only square matrices can have inverse, but not every square matrix does. So when the determinant is 0, the matrix cannot have an inverse. And if the matrix does not have an inverse, then it has only one inverse matrix. So to prove that matrix B only has one inverse, suppose that A subscript 1 and A subscript 2 are both the inverses of B. So here we're just working through the problem here of A subscript 1 equals A subscript 1 times the identity matrix. If A subscript 2 is the inverse of B, then you can do B times A subscript 2 equaling 1. And then you use the associative property A subscript 1 times B. And if A subscript 1 is the inverse of B, then A subscript 1 times B is 1. And 1 times A subscript 2 would be A subscript 2, which is the definition of identity matrix. So this will make a little more sense once we see some examples. So here we want to determine whether each pair of matrices are inverses. So we need to find the determinant of these. Actually, not the determinant, but we're gonna multiply A times B. So this is going to give us a 2 by 2. So if we multiply row 1, so this would be 2 times 3 is 6, plus 5 times -1 is -5. So 6 plus a -5 is 1. This one is row 1, column 2. So we have 2 times 2.5 minus, or not minus, plus 5 times -1, and we get 0. Next is row 2. So -2 times 3 plus -2 or -6 times -1 gives us 0. And row 2, -2 times 2.5 plus -6 times -1 gives us 1. So that matches up with the identity. And if you did the other direction, let's do the other direction here, we would have 3 times 2 plus -1 times 5. That would give us 1. And if we did here, this would be row 1. So 3 times 3 times 5 plus 2.5 times negative 6 gives us 0. And over here, row 2 with column 1, so it would be negative 1 times 2 plus negative 1 times negative 2 gives us 0. And row 2 with column 2, so we have negative 1 times 5 plus negative 1 times negative 6 gives us 1. So yes, these are inverses because it gives us the identity. Next one. So we have row 1, column 1, so 7 times negative 3 plus 4 times 4 gives us negative 5. This one I can already tell because this is a 5. No, these are not going to be inverses of each other. If I tried the other direction, negative 3 times 7 plus 5 times 4, or not 5 times 4, 5 times 5 gives us 4. That doesn't work. So no, that's not inverse. Next, let's try these. So we have 3 times 1 plus negative 2 times 1 equals 1. And we have 3 times 2 plus negative 2 times 3 gives us 0. Next is negative 1 times 1 plus 1 times 1 gives us 0. And negative 1 times 2 plus 1 times 3 gives us 1. So yes, this would be inverses. If it works for this one, it's going to work from the other direction. Next, here let's test this one out. So we have 3 times 1 plus 4 times, or negative 1 times 2 gives us 1. We have 3 times negative 3 plus negative 1 times 4 gives us negative 13. So no, this is not an inverse. Next, here we have cylinders with fractions. So this again, it's a 2 by 2. So we have 1/3 times negative 3 plus negative 1/6 times negative 6 gives us 0. We have 1/3 times 6 plus negative 1/6 times 3 gives us 1.5. So no, these are not inverses. And let's try the other one here. We have negative 3 times negative 3/17 gives us 9/17. And then we have to actually we have to take that one and add 7 times negative 5/17. And that gives us negative 26/17. So no, these are not inverses of each other. Example 2, find the inverse of each matrix if it exists. So to find the inverse, first thing we need to do is find the determinant. So this is negative 36 minus negative 3 times 17 gives us negative 51. So negative 36 plus negative 51 gives us a negative 87. So from that point, I have to take so the determinant is negative 87, so I have to do the reciprocal of that. So this would be 1 over negative 87, and then I gotta multiply that, and I switch these around, so this would be 9 negative 4 and then I change the signs of the rest. And then I multiply it. So I have negative 1 divided by 87 times 9. That gives us a negative 3 over 29. We have negative 1 over 87 times negative 17. That gives us 17 over 87. Negative 1 over 87 times 3 gives us negative 1 over 29. And we have negative 1 over 87 times negative 4. That gives us 4 over 87. Just reflecting now back on what I had, I actually did the wrong math up here. So this part right here is wrong, but my determinant is wrong because this should have been, when I'm subtracting a negative 57, that is actually negative 36 plus 51. That should give us 15. So now the determinant, so I have to multiply by 1 over 15. Now if I do that, 1/15 times 9, that'd be 9 over 15, which gives us 3/5. And then this will give us a negative 17/15. This will give us a 1/5. And this will give us a negative 4/15. So this would be our inverse. Again, just make sure you're always double checking that the operations are correct. So for here, the discriminants, we have negative 30 minus a negative 28, which will make this a negative 2. If I do the reciprocal of that, that's going to give us be a negative 1/2. Then I have to multiply by 6, negative 5, this would be 7, negative 4. So my answer would give me negative 3, negative 7/2, positive 2, and a positive 5/2. That would be the inverse of that function. Moving on, find the inverse of these if it exists. So here, this would be 2 minus 0, which gives me 2. So the reciprocal of 2 is 1/2 times. So I switch the corners around. So this would be a negative 1. Opposite signs. And our answer, half of negative 2 is negative 1. Half of 0 is 0. Half of negative 8 is negative 4. Half of negative 1 is negative 1/2. Now this other one, I'm going to use a calculator to show how you can do this on your calculator. So if I go to second matrix, I have a 2 by 2, so I'm going to edit. I'm going to go down to the third one here. So it's a 2 by 2. And then we just enter the numbers in. So we got negative 4. We have 6. We have negative 2. And we have 3. So now if I go to second, quit just to get out and go back in. If I go to math, actually not math, so you go back to here, we're going to do number 3. And if I hit this button here, it's going to give me the inverse of that one, which gives me an error message. Now let's go through it step by step to see why do we get an error message here. If I go down to find the discriminants, this gives me negative 12 minus a negative 12. This gives me a discriminant of 0. And remember, you have to find the reciprocal of the discriminant, which will be 1 over 0. You cannot find 1 over 0, so this is no solution. Or not no solution, but no inverse. That's why we have error message on our calculator. Next, find the inverse of these. Again, here I'll have 18 minus a negative 18, which gives me 36. 1 over 36 times, this would be 18, 0 here, negative 2, positive 9. This will give us 1 over 2. This will give us 1 over, negative 1 over 18. This will give us 1 over 4. And this will give us 0. So there's our inverse. And this one, half of negative 4 is negative 2 minus negative 5/3. This will give us negative 2 minus 5/3, negative 11/3. If I do the reciprocal of that, that's a negative 3/11. And then this would be a negative 4, 5, negative 1/3, and 1/2. So my answer, negative 3/11 times negative 4 gives us 12/11. Negative 3/11 times 5 gives us negative 15/11. And then negative 3/11 times negative 1/3 gives us 1/11. And negative 3/11 times 1/2 gives us negative 3 over 22. So here's our inverse. Next, matrix equations. System of equations can be solved by using a matrix equation. The left side of the matrix equation can be written as a product of the coefficient matrix and a variable matrix. The right side of the equation is called a matrix. Now, in a previous lesson, we did go through how to show it on our calculator. Here we're going to show how you can do that in the paper method. So you can solve a matrix equation the same way that you solve other algebraic equations. The solution of a matrix equation is given by the product of the inverse of the coefficient matrix and the constant matrix. So if I have A times X equal B, multiply each side by the inverse. So 1 over, opposite of multiplying by A is divided by A, and you'd have X equaling B over A. It would be the same thing with matrices. So our example here, a metal alloy is a combination of 2 or more elemental metals. For example, copper and zinc can be combined to make brass. How the alloy will be used determines the best ratio of copper and zinc. A sheet of yellow brass commonly used to make musical instruments contains C pounds of copper and Z pounds of zinc and weighs 16.4 pounds. When the price per pound of copper was $3 and zinc was $1.10 per pound, the sheet cost $38.94 in raw materials. Determine how many pounds each metal was used to make the sheet of yellow brass. So step 1, we need to write a matrix equation. So we have copper plus zinc equals a total of 16.4. And then the other one is dealing with the cost, $3 and then $1.10. And we're going to rewrite the system of equations by using matrices. So we have a 1131.1 times CZ equals 16.4 and 38.94. Step 2, you're going to find the inverse of the coefficient matrix. So to do that, we need to find the discriminant. So we have 1.1 times 1 minus a negative 3 times negative 1 gives us a negative 1.9. The reciprocal of that would be negative 10/19. So I'm going to have negative 10/19 out here, and you're going to multiply that by the matrix. And so you're going to do, this will be 1 and then 1.1 here, 1 and then positive 3. And when you do that, you end up with negative 1 or negative 10/19 times 1 gives us negative 10/19. One thing I realized that the signs are wrong up here. This should be, actually no, that is correct. Actually no, that I had it wrong down here. This would be negative here. So then this is 1.1 and this is the 1. Let me just get rid of this. So this right here is negative 10/19. So you multiply that by every term in here, and this is what you get right here as the inverse. Now from that point, step 3, you're going to multiply each side by the matrix equation by the inverse. So we have the inverse, so we have to multiply this 2 by 2 by this 2 by 1. And when you do that, you end up with C being 11 and Z being 5.4. So let's try one ourselves here. The Booster Club for North High School plans a picnic. The rental company charges $15 to rent a popcorn machine and $18 to rent a water cooler. The club spent $261 for a total of 15 items. Determine how many of each item the Booster Club rents. So we're going to use, we'll use P for popcorn and W for water cooler. So we have P popcorn plus W water cooler equals a total of 15 items. And then we have 15P plus 18W equals a total of 261. So our matrices would be 1, 1, 15, 18 times, this would be PW, this has to equal 15 and 261. Okay, we need to find the discriminant on this side, and not the discriminant, but the determinant. So here we have 18 minus 15, which gives us 3. The reciprocal of 3 is 1/3. So I have 1/3 times, and then I have 18, negative 1, negative 15, and this will be 1. So give us 6, negative 1/3, negative 5, and then 1/3. That's what I'm going to multiply on both sides. So now I'm going to take this, multiply this by 15 over 261. So I'm going to have a 2 by 1, and this is my P, this is my W. So for here, row 1, column 1, so I have 6 times 15 plus negative 1/3 times 261 gives us a total of 3. And then the other one, here we have row 2, so negative 5 times 15 plus 1/3 times 261 gives us 12. Add those up, that gives me my 15. So we have 3 popcorn machines and 12 water coolers. And our last one, Manuel and his sister both sent graduation announcements to their friends and family. When Manuel graduated in 2020, postage was 55 cents. When his sister graduated in 2016, postage was 47 cents. If they mailed a total of 156 announcements for $79, how many announcements did they send? Our matrix, we would have, actually, come up with equations first. So we'll do Manuel and sister. So when Manuel graduated in 2020, the postage was 55 cents. So they have a total of 156. And the other one, this one was Manuel's, was 55 cents, so 0.55 M plus 0.47 S equals 79. So here we'll use our calculator for this one. Go to second matrix, edit, we got a 2 by 2. So we got 1, 1, and then we got 0.55 and 0.47. And the second matrix, edit, this will be a 2 by 1. So this would be 156 and 79. Second quits, so we'll do second matrix. We need the second one, so number 3, the inverse, and then we're going to multiply that by the other one, second matrix, matrix 4, enter, and it tells us Manuel had 71 announcements and his sister had 85 announcements. That is our lesson on solving systems of equations using inverse matrices.